Hi, Thorsten. Welcome back.
Thanks for having me again.
Yeah, today all about CDKs, Java, self-mutating pipelines and stuff. And we actually discussed in depth the how CloudFormation is working, and maybe recap what CloudFormation is and what how to call it synthesis, or what is the noun synthesis, how synth is working exactly.
So CloudFormation is the underlying infrastructure as code tool from AWS. So it's a JSON or YAML format, and you describe the desired state of your infrastructure. So all the resources you want to have and all the properties they should have. And that's all that you define in the YAML or JSON file. Because not a lot of people love writing YAML, and it can be very, very verbose. So we're talking about multiple thousand lines of code. CDK came into existence where you then use another programming language, like, for example, Java, to define your constructs, your resources, and then it synthesizes to CloudFormation. So that's exactly the point where your object tree that you build up in Java is then rendered into the YAML or JSON that can be understood by the CloudFormation engine.
What I found interesting that they call it resources, because this is it matches to REST resources, and this is actually true. This is like, there is something. This is like the server, EC2 or Lambda, whatever. This is a thing which you would like to influence. So this is actually very RESTful, right?
Could also be seen that way. I think the part is that a CloudFormation resource is anything that can be created in AWS. That can be a bucket, that can be an instance, a security group, but also things like a policy or a security group, ingress rule, and things like that. So everything that can be created in AWS, and there are, I think, several thousands of them.
Yeah, pretty sure, because they have several hundred services. So and every service has a lot of resources. There are small ones and even hidden ones, like a glue between other resources. So, and whatever happens, so we mentioned yesterday, the CloudFormation resource is defined. What is it? It looks like YAML, right? It is in a central location. There is the structure of the event or resource is defined in a central place. And how to call it properly? What's the name of it? The CloudFormation colon separated resource description.
Yeah, there's the CloudFormation resource specification.
Resource specification. Okay, there is and the resource specification is actually what the cloud can deliver on, what the CLI, even CLI, right? Even CLI uses the same, whether is this like the complete description of the cloud surface, or is there more?
No, it's a different one than the API. So the API, so the AWS CLI is using a different API than CloudFormation. But the resource specification for CloudFormation contains all information about these are the several thousand resources, these are the properties, these are the return values they have. All that is defined in the resource specification. And that is used by CDK to generate the level 1 constructs, bindings. So the one-to-one representation of that YAML resources into Java objects or TypeScript objects or whatever.
So exactly, CDK. But if you would use the SDK, which is kind of a CLI and anything else, so the resources is still a valuable description, because a resource is a resource, right? So if the attributes are similar, so it is not like an EC2 resource looks completely differently from SDK point of view. You can still learn.
It's similar, but not the same. So there's another specification for the API that has also the SDK docs that has all the information in it, how to create a resource manually using the CLI or an SDK.
And what's the name of that? What's the formal name? You know it? This SDK name is also spec like.
It's basically just a documentation. It's a CLI documentation.
The CLI documentation. Okay, that's the usual one. Exactly.
Or the SDK documentation. So the CLI is just considered the SDK for Bash. So there's different SDKs. There's one for Java. There's
exactly.
Python for Photo, and so on. And there's one for Bash, and that's the CLI.
Mm-hmm. Because what I did in the past, if something didn't work in CDK, is I also took a look at SDK, and with the Java Doc, SDK was good enough, and with the SDK, CDK knowledge was good enough, to understand really what's going on.
They are very similar, not always, and I think that's a good thing, because there's a difference in creating a resource manually and defining a set state for a resource that CloudFormation should then call the API for you. Because sometimes there are things that are properties that are only for technical nature to do something, but not to define how it should look like. So sometimes CloudFormation. So for some resources, CloudFormation is just calling one API, create, and that's it. So it's a one-on-one mapping. But for some, it should do some things like create something, then create something else, and then wait for something to happen. A bit more complex, and that's where then the APIs differ from the resource specification.
So if you think about this, I think it's even true, right? That the CDK and CloudFormation is like a resource-oriented architecture, more like RESTful. And the SDK is more like a remote procedure call, and they have to be similar, but it is harder to describe flows with CDK, or actions, and the declarative way is harder with SDK, because it will end up being CDK. Yeah, this is actually, and this is occurred to me right now, that actually CloudFormation is more like RESTful. And the SDK is more what we always had, was like imperative, action-oriented stuff, right? And they, of course, and in the ideal world, there will be one resource which will be influenced, like the state transition between resource, like installed, not installed, would be, the resource would be the same, but from SDK point of view, maybe there would be more actions than from CDK. This would be the perfect world, right? Yeah. Yes, fascinating actually, if you think about this, because this is old and well thought through, right?
Yeah, sure.
Yeah, because I don't know whether you remember, but back then, AWS always had it. They started with SOAP, and then they did the REST, not CloudFormation, but the API, and there was lots of discussion in Java and web services world about how to design REST services, also authentication, because what AWS introduced was the signing of the request, which was actually a great idea. And I think in Java no one had it, so there was like, this is an interesting way of doing it. So they did it right long time ago. This is the interesting part, right?
Yeah, and the underlying API, so the AWS API is still a SOAP API.
Mm-hmm.
So the SDKs are basically calling the SOAP.
So we cannot say it loud, but it is like it is, right? And what I also remember, there was a kind of a drama, because what companies started to do at the beginning of the SOAP API, they offered additional management. You remember that? There were companies who used the WSDL from the SOAP to create another cloud and also to be managed. I forgot the name. There was at the very beginning, so the first infrastructure as code companies before Terraform was in place. There were bigger companies who picked the WSDL and generated code and offered our own product back then, what I remember. And no one was sure, can we use it or not? This was back then a bit of a drama. I forgot the company.
But there were several different UIs for AWS. I'm also I remember using one. I don't remember the name, but we used something for autoscaling groups, because autoscaling groups in AWS in the beginning were available using the API, but not in the EC2 management console. So you could not configure autoscaling groups in the console. So there was another service that we bought in a company where I worked for to manage autoscaling groups in the UI and launch configurations and so on. And there was a separate product using the AWS APIs to manage autoscaling.
And the CTO or CEO was Michael something, and it was a big deal because they were they were huge actually. I have to look it up because the name of the company was actually great, and they were also Java conferences. This is why I remember that. It's like an association happened right now. Okay, so we have, and this also maybe explains why we sometimes need custom resource, right?
Yeah, so for some things, so custom resources serve two purposes, I think. One is a resource is not in CloudFormation for reasons. Why? Because the team didn't have time, didn't have the knowledge, whatever, to build a meaningful CloudFormation resource. So that's then when we need a custom resource in CloudFormation to build that up. Or sometimes we need to have some actions. So we don't want to define a state. We want to do something. And this doing something then also needs a custom resource. I think a prominent example of that case is cleaning buckets. So you want to get rid of all the objects in an S3 bucket, which is not it is a desired state. The desired state would be it's empty, but that's not implemented in CloudFormation. You cannot tell CloudFormation this bucket should be empty and then it's deleting everything. That's why we need a custom resource that is then called and is destroying or deleting all the objects in a bucket, which is important to then delete the bucket after that. So that's, I think, the two things for custom resources is one, missing implementations in CloudFormation, and one is having actions that are one-off actions or actions that are not a state of a resource, but something that's happening. I think these are the two things where we need a custom resources.
Extreme case could be order and domain, right?
That's also something you could build as a custom resource. I would argue you can define it as a set state. Like I want a resource to be, the domain to be there. And buying the domain is part of the creation. That's not how it's implemented. So yes, you would need a custom resource for that.
Yeah, because this domain is the remaining thing which is really annoying and how to automate. Because if you need the domain, you have multiple accounts, multiple stages. And the other one, which is a bit annoying, is the SES email approval, right? So that it cannot be automated.
Oh yeah, and it just occurred to me there's a third way where we need custom resources, which is getting data. So sometimes we need information from somewhere, and then we can build a custom resource that is just calling an API and returning the result. So it's not really a resource that is creating something. It's more just a resource to fetch data. In Terraform, it would be a data resource, I think. Just to have something. An example that I have with my customers all the time is if you create a VPN connection, for example, or a VPC endpoint, you want to have the ARN or the IP address of that. And that's not a property of the resource. So you need to have a custom resource to describe it and get back the IP address if you want to use that in another step.
In another step, okay. Because I also worked with the VPNs, and I think, but I just had my own connection to VPN to private VPC, and I just used trivial stuff output, and I saw the IP address or the link, but I couldn't use it after that, right? So what are you saying? Okay, that's interesting. So if we do more, will you? Okay, interesting. So using data in order to pass the data to another resource.
Exactly. Then you sometimes need some describe calls in a custom resource.
And what takes to implement a custom resource?
That heavily depends on the type. So if the custom resource is only doing exactly one SDK call, like describe network interface or whatever, maybe even purchase domain. So if there's one SDK call to do that, there is in CDK something called the custom resource providers or the AWS custom resource provider. And you can just specify the API call that should be done, and you don't need to write any code. So CDK is deploying a Lambda function for you that is doing exactly that one SDK call and returning the result as outputs. So you only need to specify basically the string or the name of the SDK call you want to do and the properties.
Sounds almost like step functions, the API integration.
It's very similar to the step function API integration. So, and if you want to do more or multiple calls, then you would just need to create a Lambda function and hook it up to the custom resource provider and say, yeah, here's the Lambda function, call that whenever you need to create, modify, or delete that resource. Please call the Lambda function.
And the parameter is just my parameter. It doesn't matter. So what the API is, or is it a specific API?
So the API of your Lambda function would then be, it's a create object, create event, it's an update event or a delete event, and the properties that are coming from the resource. So the properties that you set, like with all the other resources, and then your Lambda function needs to handle that case. So is it creating something? Is it modifying something? Or is it deleting something? And that's it. So it's basically just a Lambda function. You can do whatever you want. You can describe something.
Okay, then is there no difference to S3 events? You get just the CDK event, the resource event, and everything is encoded there.
Yeah, and then you just need to do whatever you want to do, even call an outside API. So, for example,
this is just a declarative. You only declare what the name of the Lambda is, and it's called, and you're done.
Exactly. So for one customer, I'm adding PagerDuty as CloudFormation resources because obviously it's not an AWS resource, but we want to manage it from the same CDK stack. So there's a custom resource that's creating services, modifying services, and deleting services in PagerDuty as a CloudFormation resource.
Yeah, this is actually great use case. It's a third-party integration, right? So PagerDuty is not it's not AWS service or whatever you have external. You could do this. I look at this, but it was, I think, before V2 or as CDK V2 started. This was and for Java back then, it was not that easy to do that. So, and what you're explaining right now is super easy. So did they change before V1 and V2? Or was it like simplification? Because what you're explaining right now, it sounds to me like I could implement a Java Lambda because I have already the entire infrastructure in place and I get the event. And if the event is not supported in Java, I don't care. I get the raw JSON. I can parse it and do whatever I like, right?
Yeah, so it got easier because of that resource provider framework. So they built that custom resource provider framework that is handling a lot of stuff for you. Because in plain CloudFormation, your Lambda function needs to call a pre-signed URL with a response. If it doesn't do that, so the happy path is always easy. You just need to call a response and that's it. But if you don't call it and you lose the token, then you basically wait 2 hours until CloudFormation times out. And there's a lot of things that go wrong during development. And with the resource provider framework in CDK, it's handling all the edge cases for you. So you don't need to format it in the right way and send some weird stuff to CloudFormation. It's just you're getting called with the event, you're returning a response, and that's it.
Okay. And could I use the custom resource provider to call my Lambda?
Yeah, that's exactly the way it works. So you build a Lambda function, and then you create a custom resource out of the provider, and you tell it the ARN of the Lambda function it should call.
Okay. And when it was introduced, the custom resource provider? Like recently, so
not recently, but it could be that it's a V2 thing. I'm not sure.
Yeah, exactly. Because I look at that, and what I decided back then is step functions and SDK. So it was more transparent, because it's a more evolved process. Yeah. And but it sounds like almost what I did was exactly this.
So especially the AWS resource provider is really cool because a lot of the times your custom resource is just calling one SDK call. And then you can just let AWS handle it or let CDK handle it completely for you. And you don't need to write any code. And not writing code means not handling updates and dependency changes and rebuilding stuff.
Yeah, it's very good. Serverless.
Yeah.
Pretty cool. So would it... Yeah, exactly, just best practice. Would it be a good idea, let's say, to write a custom resource to access S3 bucket, let's say, and this S3 bucket contains more evolved configuration and use the configuration to drive the CDK or a database or whatever, that you have like SaaS-like product. So you have in the bucket the configuration or the DynamoDB, doesn't matter. And you could specify there whatever client names, account names, DNS, and then instead of running the CDK from your machine. It will run in a pipeline, and you will get the data from an external data source.
I don't want to say that there's never an option to do that, but in general, I prefer my CDK code to be deterministic.
Mm-hmm.
So if I need something like that, and I have a customer right now with a similar use case where it's creating multi-tenant stacks.
Mm-hmm. And we forgot to mention your name of the company is Thamos, right? Thamos?
Yeah, Thamos.
Thamos, and you're providing services for security, serverless, cloud migration, and whatever compliance, right? Compliance,
exactly.
And okay.
Yeah, and CDK reviews, CDK development services, and so on. Yeah, so with one customer, that's exactly the point. They want me to build a multi-tenant CDK deployment for them, and there it is handled by getting dynamic inputs. So also not something I love, but in this case, it's the best idea for this multi-tenant system is having a dynamic input to my CDK synthesize and then synthesizing based on that input. The benefit is I can use the full power of the CDK code with if, with while, with all the things that you have in your programming language to react on that multi-tenant configuration instead of resolving it in a custom resource and then being limited to the CloudFormation features of, if this happens and if this is a return value, do something. It's way more limited to react to these dynamic things.
So because if I would implement the custom resource, I'm already in the process of synth. But if I could do something before.
Even deploy. The custom resource is running at deploy time.
This is too late, right?
And for some things, if you just want to change a value, that's fine. If you want to return a list and do something for each, that's not possible in CloudFormation.
And you say a dynamic input. Is this the context? What you are saying?
You can use context for that. In my case, I'm using environment variables, but that it's just a way of bringing information into the code. So you could. There's multiple ways of bringing it in. One way that is not happening is looking up something dynamically. So you cannot call an API from CDK.
But parameter store is kind of, right? You could.
Yeah, but that's also deploy time.
Okay.
So during synthesis time, you cannot do asynchronous calls because the whole synthesis is a synchronous invocation. You cannot do an async call to something during that.
And how this works is that you get the placeholders, right? So they look, I forgot actually how they look, but so if you specify what you can specify, output whatever, so the CloudFormation doesn't know all the names because not deployed yet. So the final names are replaced. So all the references are handled like a markers, or how to call it, like placeholders, right? Tokens, exactly. That's the token.
That's for the dynamic things that are happening during deployment. But for the multi-tenant stuff, that would be already in the CloudFormation template. Because I'm really in the synthesis code, I'm just filling a variable with a value that is coming from an environment variable, and then using that in my code. So my code, it would be, from a code perspective, exactly the same as the tenant information would be written in the code.
So what you're doing is actually what I'm doing. So so you have a, let's say, TypeScript code, I have a Java code, and what we are doing is you have a logic which runs and defines, the variables, right? It's like regular Java.
Yeah, and then the benefit is I can do, if that value is that, I can render resources or skip it. If there's a list, I can do for each and create resources. So I have the full power of my language, or my programming language in CDK, and not limited to some of the intrinsic functions of CloudFormation. So
what I did recently, a few years ago, is we had a configuration like dev and prod, and in the dev configuration I have different settings for cores, for instance. And but the core settings were in the stack, but I could configure the stack before, also in Java code. This is what you're referring to, right? So I could. What I did, I fetched from my environment, which was the pipeline. So I knew which environment am I. So okay, I'm in dev or prod, and in prod I got the production, course, and this was important because only in production I got the DNS names, and in dev we have no looser core settings, for instance.
Yes, but so that's not even multi-tenant, that's multi-stage.
Yeah, multi-stage.
And these stages are basically defined up front. So what I'm doing in that case is my CDK entry point, so my main TS or main Java or whatever, is creating multiple instances of the stack.
Yeah.
So my stack class.
Yeah.
And I'm doing new my stack
exactly.
with settings for dev, new my stack with all settings for prod. So all my settings are in there with multiple invocations of the stack class. And the synthesis creates all templates. So
exactly.
Synthesis creates a dev template, a prod template, and so on. And then I use the right template out of the CDK out folder.
Yeah. So, and I use that enums for that, work perfectly, and kind of a factory. So with a factory, because nicer builder pattern is okay, this was on the stages were encoded in enum, and depending on the stage, the right factory method was called. But this was not dynamic, you're saying.
That's a big difference. So I'm always synthesizing all environments, and then on deploy, picking the right template. But I'm all synthesizing, and not synthesizing one based on the environment, but synthesizing all of them. All the time, and then deploying one of them. That makes sure that even during the dev build, I'm sure that prod still synthesizes. Otherwise, you get a problem that you're working on dev all the time, everything's fine, and the moment you want to go in production, you figure out that production is not synthesizing. And if you synthesize all the environments all the time, you fail early and see, yeah, this is fine, but it will not work in production.
But in production, I would get also a minimalistic pipeline, right? So I will find it out. But you would like to fail earlier. So
yeah, I want to synthesize once. I want to synthesize exactly once. So my pipeline is working. It's exactly like the CDK pipeline is working. It's synthesizing once for all environments. And then it's only deploying that synthesized templates in different environments, but it's never rebuilding. So for all environments, you exactly build once, and then you just deploy the templates.
Yeah, which makes sense. That's exactly the same in Java. We have one jar, and we push the jar around.
Exactly.
Okay. Then what you did with the dynamic, what you did exactly. So you passed variables to one stack, which was dynamic, right? So you had like parameters in the stack, and you pass from outside, from environment or whatever, and then it was backed in, right?
Yeah, that's for the multi-tenant, exactly, because the multi-tenant setup is not dev stage prod.
Yeah.
It could be 10, 100, whatever, and that's then where I go to really having dynamic inputs, and then I'm going back to, I'm synthesizing per tenant.
And even worse, what can happen is that you have tenants with the stages, and if you have a product, you have the stages first, and then come the tenants with production only, right? So this is really differs, and we had sometimes problems that specific tenants had more security. They wanted to know when's released or whatever, and we couldn't just ship one thing everywhere. But So you like CDK? Is there any reason to use Terraform, for instance?
So I'm using Terraform for cross-cloud stuff, or third-party stuff. So setting up GitHub repositories, setting up a direct connect, and also configuring the on-prem machines on that direct connect. And so whenever I'm leaving the AWS boundary, sometimes it's easier to use the Terraform stuff. But short plug on that. You can also use CDK Terrain for that, which is the successor of CDK for Terraform, where you can use the CDK deployment and development model, but it's then synthesizing to Terraform instead of CloudFormation.
What I thought is that it will use not the Terraform synthesis to Terraform, rather than have a custom thing which calls the Terraform APIs, the Terraform resources directly.
No, it's just it's exactly the same way as CDK. It's synthesizing, and the synthesis creates a Terraform script instead of a CloudFormation script.
Yeah, it's also cool.
Yeah, and then you use Terraform or OpenTofu apply, and it's applying the same stuff. So it's
what's the impression? The Terraform has to die out a little bit, right? And OpenTofu has to gain momentum, actually.
I think that heavily depends on who you're asking. For enterprises, they're completely running on Terraform. For everybody outside of enterprises, it's OpenTofu all the way.
Okay.
So, yeah, let's see what happens there. You never know with HashiCorp right now, but
yeah, HashiCorp is IBM right now, right? So
yes,
yeah, and it's really interesting what happens because it's a similar story to Hudson and Jenkins back then, almost identical, right? So and as long as they are compatible, no one cares. But if OpenTofu will provide more features and more resources, it will move faster. Then it's actually almost identical, right? So back then, Hudson was Oracle, and Jenkins was Community. And Oracle said, okay, we will keep, working on Hudson. But then the community was faster. This was exactly the same situation. Mm-hmm.
Yeah. So I think that's time will tell if it's Terraform or OpenTofu. But yeah, the thing is, even if you want to use Terraform or CloudFormation, you can still use CDK. There's a definite feature set. So definitely the CloudFormation CDK has way more features with level 2, level 3 constructs and asset bundling and all that stuff. That's not there in the Terraform version of CDK, but time will tell. So now the community has taken over the CDK terrain. It was also done by HashiCorp, but now the community has taken over. So maybe there's also a lot of features coming.
Yeah, that's interesting. What I learned is, I think last year there was the first incompatible features happened, and this would be interesting,
on Terraform and OpenTofu.
Yeah.
So currently CDK terrain is compatible to both, but also that might change if the underlying features of OpenTofu and
this is interesting. They will also have to pick, right? Or because I don't think they will synthesize to both.
Yeah, that would be an interesting thing.
Yeah, really interesting. Okay, interesting. So now, after half an hour of deep dive, we should start with the basics. And so I have Java code, bucket, builder, create, and create S3 bucket. What happens there? So there's a Java, and we have synth. So from the Java perspective, what I already know, there are two dependencies I need. One is called constructs, and the other one is the CDK. This is two Maven dependencies. Yeah. And then I need a little code, a main method basically, and which creates an app. And then I need at least a stack, pass the app to the stack, and call synth. So this is the developer view. This is what I do, right?
Exactly.
Yeah.
So what you're building in your code is basically an object tree. In CDK, they call it a construct tree that starts with an app at the root. An app has one or multiple stacks, and each stack then consists of multiple constructs that can, again, contain constructs. So you're getting a tree. And at all the leaves of that tree, you have level 1 constructs for CDK that directly map to CloudFormation resources. So during synthesis, that whole tree is analyzed, and all the leaves are then rendered into the CloudFormation JSON or YAML. If you're using Java, that happens in multiple processes. So you have your Java process that is building up your Java object tree. But for the implementation of all that classes, it's doing a remote procedure call to a node process that is running CDK, because CDK itself is written in TypeScript. So your class that you're instantiating in Java is just a facade that for every method call is doing a remote procedure call to the node process.
Which runs locally.
The process is then invoking the node implementation of that resource and then giving back the results, serializing it again, coming back to your facade so you can work in Java. But at the end, it's rendering a YAML or normally a JSON file to your disk that contains the CloudFormation template. So the most important thing, and I want to reiterate that on all occasions, is CDK is never calling the API. So CDK is not creating resources. CDK is creating a text file. And then this is sent over to CloudFormation, and CloudFormation is creating resources for you.
So the Node.js just basically serializes the thing to JSON, but it also has to maintain links, right? This is the main problem. It's like the referential integrity.
Yeah, and it's doing that, and it's also implementing. It's also the implementation of what's happening. So the bucket, you mentioned the bucket.
Yeah.
So you Java class bucket, and what happens in that class is not in Java.
Mm-hmm.
So when you do new bucket in Java, the only implementation of the bucket class is calling the node process and tell Node.js, hey, there somebody called new bucket, please do that. And then the implementation of the constructor of bucket is happening in Node. And the response of that, so the created object that was created now by that Node process, is then sent back to Java and like, yeah, here's your object.
Mm-hmm.
So all method calls are happening in Node.js. The Java implementation is just a facade for all methods to call the Node process.
Because we could serialize the entire Java tree directly to JSON. Could work actually, right?
Yeah, but then you would need to have the implementation of the constructors. Like, okay, new bucket is creating a bucket, a CFN bucket policy. All that information would be needed in Java.
Yeah, okay, because in Node 1-to-1, we are level 1. That's the problem. This is the mapping.
For level 1, it could be.
Yeah, exactly.
Constructs where some logic is in there that would be needed to split out in multiple languages and re-implement it. And that's why it's all just facades calling the Node.js code that is then really doing the implementation.
Accidentally, a few years ago, I ran, I think 1 year, Node.js on GraalVM because of misconfiguration. I did a lot with GraalVM. And this would be actually a cool experiment because if GraalVM, Node.js runs on GraalVM and Java runs on GraalVM as well, then the remote procedure is not remote. It's like, in process call. This could be interesting whether there's any performance difference or not. This would be interesting to see. So, yeah.
I can definitely see that. So that's definitely something you see in the metrics is using other languages like than TypeScript. The synthesis gets slower because every method call that's happening during synth is doing an RPC to the node process. Mm-hmm. If it's inside Node, obviously it's not doing RPCs, calling the method.
Then I would, verse investigation with a little of time that run this CDK process on GraalVM because GraalVM is Node.js compatible and this is all Java and it actually runs faster than Node. So it could actually happen. Then running Node on Graal could be actually faster than without. So there could be interesting experiment. It could
be interesting to change the facade of the JavaScript, the Java implementation facade to not do RPCs but running the subprocess in Graal. Yeah, that would be a feature of JSII. So to do that, the CDK is using a tool called JSII, the JavaScript job interface. Which is doing all that rendering and creating facades and transpiling into multiple languages. It's also built by the CDK team, but they externalize it in a different product because it's also used in CDK Terrain, in Progen, in whatever you want to build.
What is Progen? Progen is
a Progen is another CDK, but it's not meant for creating and rendering cloud resources, but for creating and rendering project configuration files like XML, the package.json, the TSLint config, the gitignore file, the npm-rc. So all your config files in your repo that define your project can also be defined in a object-oriented way, exactly like CDK is doing for cloud resources. You can specify, I want to have my new fancy company project. These are the 20 settings. And then it's rendering all that configuration files for you. And you can ship that information to the other projects and make sure that all your 50 microservices are using the same configuration for all your things that you need to set up.
So in Java, a bit less interesting, right? A little bit, because if you have Maven, this is almost like a Maven, right?
If you're only running a Maven, you can do that with a parent POM, I think. But so looking at the Node ecosystem, for example, all that is spread around in 50 files that you copy paste, and then having some kind of centralized way to manage that is definitely a lifesaver.
Yeah, absolutely. I'm just thinking, how to use it because it's an interesting tool.
It's also interesting in Java because, the POM XML contains all your project stuff. But then if you're running on GitHub and you want to have all your GitHub workflows being the same in every project and all that stuff can also be managed by project. So it's managing your GitHub or GitLab workflow files for you and things like that.
Mm-hmm. Okay, so we have this CDK and this CFN. So this is CloudFormation resources. Are they level 0 or level 1? Level
1. So there is a level 1, 2, and 3. So level 1 is the CFN bucket, to stay with the bucket example. The CFN bucket is just the identical representation as the CloudFormation bucket with the same properties, no type safety, everything is a string. That's the level 1, the CFN bucket. And then there's the bucket, which is the level 2, that makes this type safe. So things that are strings, things that are enums are real enums, and things that are numbers are numbers. You get type safety on what you can configure. And also, the bucket is not only creating a CFN bucket, but also a CFN bucket policy. Because in CloudFormation, the bucket and its policy are two resources. But from a developer standpoint, it doesn't make any sense because you just have a bucket and it has a policy. It's a property of the bucket. So in level 2, there's one bucket. In level 1, this is already the bucket and the policy as two resources. And the level 3 is then whole patterns, like staying with the bucket example, that could be a website that has a bucket and a CloudFront distribution and a domain name. So combining multiple services into a pattern is then a level 3.
Genau. Exactly. And one example is the Fargate, right? Because the L3 Fargate ECS, this is a pretty if you're lucky with one class, one builder, you have the entire thing. If you're not lucky, you still need some hacks, but it's pretty easy to start with Fargate with level 3.
Yeah, that's one of the best examples for L3s. It's the application load balance Fargate service. As you can see,
exactly.
So the class name shows that there were Java developers on that.
Okay.
How it should be manager or factory, but then it would be perfect. But the application load balance Fargate service is exactly that. It's creating
how JavaScript developers would call it.
Good question. I don't think they would do that. So no, the thing is, it's creating a certificate, a domain entry, a load balancer, and the Fargate service, the Fargate task definition, the cluster, even a VPC if you don't specify one. So all the resources that are needed. I think I tried it out for one of the workshops. It's creating like 900 lines of JSON for CloudFormation with one class.
And it's usable. It's actually pretty usable. It's perfectly. But we had to do something where we hit the limit. I forgot what it was, and then it became ugly because I had to do some. I forgot what it. Maybe private VPC, something something which was a little bit harder, and then
sure.
Yeah.
So the idea is from level 1 to 2 to 3, there's abstraction. Abstraction always makes it easier by hiding options.
Yeah.
So you're taking away options of the user, which makes it easier for the user. So you have one class instead of 50 classes. So it makes it easier, but that abstraction comes with a cost, and the cost is flexibility. So if you're fine with how the L3 works, you can save a lot of code and time and understanding. But if you're not happy with the L3, then it's very hard because it's at some ways it just took a different decision than you want.
No more convention over configuration, basically, right?
Sorry?
Convention over configuration. So this
exactly.
Conventional.
So if you follow how it is meant to be used, it makes it way easier. If you want to fight the construct, then it's easier to use an L2 or an L1 if you want to build it exactly how you want it to be.
But and the reason why we got L1 is because the CloudFormation team is faster than CDK team, right?
Obviously, everything needs to happen in L1 first, because if it's not in L1, we cannot use it in an L2 or L3. And then so the L1s are generated out of the resource specification, so they're there immediately. And then somebody needs to build an L2 out of it that makes it meaningful. There's some changes coming up right now that are, I think last week there was merged with the CDK mixins, which is now starting to give you a way of using L1s, but combining them in a meaningful way. So getting some of the L2 features without somebody writing all the L2s for you. So if you don't want to have the full-blown L2 or L3 with all the opinions in it, but just want to use a feature like please encrypt my bucket, that's what a mixin can do, to just modify some things, but you're not either or. Currently,
we forgot to mention that.
Or use the opinion.
We cannot mix L1 and L2. This is annoying because sometimes you're perfectly fine with L2 and you are missing something, and you cannot just use in this particular case refer from L2 to L1. That's the problem.
Yeah. Mm-hmm. And with the mix-ins, you can do like, here's my L2, but then please change these things on an L1 level.
Mm-hmm. That's actually extremely usable.
Yep. And that is, so the RFC was merged 2 weeks ago, and the first mix-ins are landing in CDK right now. That's also why CDK and all the relevant things, and you mentioned the other library, is the constructs library. The constructs was upgraded to 10.5, and you now need to use the 10.5. You mentioned earlier, so we have the CDK library that contains all the classes for CDK and all the things. And there's this second dependency, the constructs. And that constructs, it's a very, very light dependency. It contains only the construct class, the resource class, so some generic interfaces that are used for all the resources. Mm-hmm. And it's a separate library because it's exactly the same library that is also used in Progen, in CDK Terrain, in whatever other CDKs that are out there that are not using CloudFormation are still using the constructs library. Mm-hmm. Which is the underlying foundation of that tree. Mm-hmm. And that got updated last week to 10.5 because it now has that methods for the mix-ins that now possible for all that CDKs to use that mix-in feature.
Mm-hmm. And how would it look like from syntactic perspective, such a mix-in?
The mix-ins, so what was added in 10.5 for the construct was a method called with. Mm-hmm. So every resource or every construct now has a method .with, mm-hmm. and you can provide an array of mix-ins. Mm-hmm. And then at that point, it's a bit like aspects, but immediate. Mm-hmm. So aspects are happening at the end of synthesis, mm-hmm. and mix-ins are happening right now the moment you apply them. Mm-hmm. So I can do new bucket, and then on that bucket object, do .with bucket encryption, for mm-hmm. example, as a mix-in. And then it will call, with again via a visitor pattern, it will call that mix-in for all the resources in the tree and check if they can be applied and if it needs to modify something on the bucket.
Mm-hmm. I did with the aspect something. It sounded similar with
Very
Lambda.
Similar. The aspects, the only thing is the life cycle. Aspects are happening after the construct tree is built, right before synthesis. And the mix-ins are happening immediately the moment they are called.
Mm-hmm. I needed the aspects for Lambda, and maybe it was at the beginning the snap start. It was not exposed via CDK.
Exactly. So that's the thing. But if you want to modify something, but then not use it anymore, but just modify it for the sake of modification, like adding a layer or adding an environment variable to everything or adding a tag, that can be done using the aspects. But if, for example, there's a bucket, you want to have encryption, and in the next line you want to use that encryption option for something, then you need to have it immediately applied. And that's where the mix-ins come in.
Mm-hmm. Yeah. Which means the immediate apply. So I could mix-ins, I could use CFN or whatever, right? Or you know what I'm thinking about? So I have a CFN, let's say I have a bucket with CFN because L2 is not available, let's assume. Yeah. So, and I have what else? CloudFormation, not CloudFormation, CloudFront. And CloudFront needs a bucket. So then I could tell CloudFront with and pass the reference with CFN. Mm-hmm. This is how this would work?
That's some things of that are enabled. A better example would be encryption or auto deletion. So consider that the bucket has that auto deletion feature that when it's deleted, it's automatically deleting all objects, which is an L2 feature.
Yeah.
If you have an L1 bucket, you cannot use that feature. So right now you would need to switch everything to an L2 just to have the auto delete feature. Sometimes this is not possible because the bucket is not something you created. It's an underlying bucket in another concept.
Yeah.
Now what you can do is get that bucket object, that CFN bucket, call with auto delete.
Yes.
And then auto delete is added on top of your L1 bucket, and it's not only available to L2 buckets.
But from where? From L2?
The implementation is externalized into this mixin, and whatever the L2 is doing,
okay. Now I got it.
By the mixin.
So L2, so you cannot mix L1 and L2 still, but what happened is they factored out some interesting functionality from L2 to a central location, which can be mixed with L2 or L1, right?
Yeah.
Okay.
And the final idea is that all the L2s don't contain any logic anymore.
Yeah.
But the L2s are only a combination of that L1 with this 5 mixins.
That means L2 will die because L2 is L1 plus mixins.
It will not die. It will be a pre-curated selection of mixins.
Only the convention. So the type safety we need still, the API surface, but the API very thin layer we just call the mixins and then we are done. Right?
Yeah. So the constructor of L2s in a final idea will be creating an L1 and applying a certain set of mixins that are predefined.
Yeah, not bad. So it's a good approach. What I'm wondering still, why sometimes it's not easier possible to combine L1 and L2, just reference,
That also changed. There was some change in Q4 that the interfaces got some IREF something information.
Oh.
So for a lot of things, you can now use L1s instead, or put it the other way around. I think there is a from L1 for a lot of L2s. So you can do bucket dot from L1 ref or from CFN ref, and you give it an L1, and then it behaves like an I bucket. It's not a bucket, so you cannot do all the things you can do with an L2, but you can reference it like an L2 as an I bucket reference.
This is just a matter of types, because I thought it was like a deeper, because I never understood why it doesn't work. It has to be the same resource. This is just different representation of the Java, but this just about types is actually a cool story.
Yeah, so I think it depends on, if you only need a reference to it, then it's perfectly fine. You can use an L2 or an L1 because you just need basically the ref or the ARN. The moment you want to modify it, sometimes it can only be an L2 because only then it has the methods of granting stuff and creating auto deletion and all that stuff that can only be done with an L2. But if it's only for reference, as with your CloudFront and bucket example, that should now be possible with the from L1.
Yeah, and this happens actually, interestingly, often when new service is introduced and you combine it with old one, because for the old one you have L2s, and let's assume durable functions for Java will come out in one point of time, then maybe we get CFN first, because the L1 first. I always thought this is L0, the CFN. L1 first, and then but I have all other resources are already L2. So with that is perfect, because I can, the new service, I will use the low-level API and then upgrade if it's available, which is beautiful.
Exactly.
And refactoring was already available, was introduced last. So refactoring in renaming of the logical IDs. There is a way to do that. It was
introduced in September 25. And it works. It has some, refactoring is always hard. It's not an automated process, like magically it works. So there are some rough edges for some use cases, but with refactoring, it's now finally possible to restructure your code. Like, I want to move that from one point in the construct tree to another point, then run a refactor, and it's still working. The only recommendation here is don't refactor everything and then do the refactor call, because that might be just too big and then it breaks. So do small steps, refactor small steps, and don't rewrite the whole application and hope that refactor is now refactoring 200 resources in the correct way.
Always a good idea.
Do it in small steps. I had that with the customer. But refactor works.
What will it take to create my own L3 construct and publish it to ship with CDK? Is it possible, or is it?
Yeah, you can just build it. So there's two ways to that. So if you know that all users will be Java, you can write a Java library, like every other Java library, depend on constructs and AWS CDK lib. Create your class, your construct class that is calling other constructs in a constructor, and just ship it. And everybody's able to use it in a Java project. If you want to be able to use it in all the JSII languages, then you need to write it in TypeScript and use JSII to transpile it to all the other languages. Then your construct can be used in TypeScript, Python, Go, Java, .NET, whatever. Exactly. And then publish it to the package manager of your choice. So
is there not a way with the synth? Because from the technology, from the tech perspective, it should be possible to write it in Java. Then let's create, the JSON representation, and then create the TypeScript from it. Like reverse engineer. So cross compiling Java to TypeScript using the Node.js facility, because you know what I mean? Because the TypeScript will look like Java almost.
Yeah, I think there will be a way to do that. Writing code for that, to do that for you, might be a bit complicated. If you really want to go down that route, I would say write it in Java, use an LLM to transfer it to.
Sure. Yeah, of course. Yeah. This is very simple. No, this is not a problem. Just thinking loud onto. Because lots.
I don't think I would write a transpiler for that. I would use Claude and tell it, please rewrite that in TypeScript.
Yeah, sure. Or open rewrite. Of course, we can absolutely do that. But what I thought more automatic way, because if we have already the JSON representation, maybe it is easier or not easier, more exact, because it is what CDK.
It's not about synthesis. So your construct has all the logics inside of it.
Yeah, exactly. Yeah, that's the problem.
It's really a code transformation. So the general idea is, if all your customers are using Java, write it in Java, bundle it as a Java library. If you want to make it available to everybody using CDK, write it in TypeScript and use JSII.
Yeah, and how high are the chances that will be included in the official distribution? So what is the process not to do that?
That depends. So there's multiple options. Either you're publishing your own library, then it's up to you to do it. There's the open source, the open construct library, where the community is collecting constructs. There's a high chance to get in there, especially because I'm a maintainer. So just ping me.
Okay. Interesting point. So if someone would like, to publish something, they should ping you, and So
there's one way is just publishing it on your own. There's putting it into this open construct library, which has the benefit that it's one library. It's easier from a supply chain perspective to get used by enterprises that don't want to use a random library from the internet. And if it's a meaningful construct that a lot of people can use, there's also a chance to move it into the core CDK library. So this is so great, everybody needs it. And then create a pull request on official CDK repo and put it in there. But there's a higher bar there, because they don't want to load the library with billions of constructs that are only used by a subset of people.
I think it was a good discussion about CDK, right? We covered we covered everything? Not everything, but from CDK perspective, a lot, right?
Yeah, we covered a lot of things.
Yeah, what we didn't mention explicitly, that the IDs in the constructs and stacks are more like, I see them as maybe Java attributes. So you cannot just easily rename them without refactoring, because this will break. And or maybe IDs in JPA or Hibernate, because if you change the ID of existing object, you cannot merge it. It will create a new one, but the old one still exists. And if the problem is, or no problem, if the resource is has IP address or has a name DNS, then you cannot just easily create two of the same type, and then it will lead to errors. And this is and this refactoring will care of that. So exactly. Because I think the only thing, first, the syntax is a bit strange for a Java developer at the beginning, but you get it in 2 days. The builder-like pattern. This is actually good. And what you have to do, I like good names. So I think you know how to name the resource properly. And because if it is hard to change it later.
Yeah, that's the thing. You definitely should think of it before. Changing your construct tree is hard. But on the other hand, writing it, you don't need to have a lot of framework knowledge. It's more like just building an object tree.
Yeah.
It's nothing more than an object tree.
Yeah. And naming also, you have to be careful because I like also nice stack names, right? And the stack naming patterns are with dashes. So I spend a lot of time to try to find out what the conventions are, and they are not always consistent. But dash seems like the stack name is like, if you go to CloudFormation, you see, I think, lowercase and dashes, and the logical names are more like kebab case. Camel case, right?
Yeah, even Pascal case, because you start with an uppercase letter.
Yeah, Pascal cases, exactly.
Yeah, so that's exactly the idea, having Pascal case for resource names, and then that would be a kebab case, I think, with lowercase and dashes. The idea why to do that is some resources create DNS names out of it. So you want to make sure that you're not using fancy characters that cannot be in a DNS.
Okay, makes sense. Because
those special characters.
Because what I did at the beginning, I did a lot of research before I created a resource in Fargate. I just took a look at the AWS examples and said, okay, how they name things, and this was not always consistent. Interestingly, so I tried, to find, the best practice, how to name things, and then I found this the camel case or Pascal case, like Java class names. So this is you can use for constructs. And the names of the stacks is like the infrastructure microservices are separated by dashes, and in my case is a lowercase.
Exactly.
Super cool. We covered a lot. What didn't cover was the self-mutating pipelines, which are fascinating. But
yeah, but I think that they're losing traction because they're using code build and code pipeline and all the stuff, and with GitHub, GitLab, and all the other tools out there, less people are using code pipeline.
That's the question. This is interesting what happens, because what I found out is that less and less people actually like GitHub.
That's awesome.
This is like, and what I don't understand is if I am on AWS, really, I think code build or code pipeline is way easier than GitHub plus AWS. So if I know in my own project on GitHub, I can just do GitHub Actions. But in that AWS, the code build is really simple. I have to say I have complete control. The GitHub Actions are cool, but if I have to call from GitHub Actions AWS infrastructure, is not as easy.
Yeah, that's with OIDC. That's pretty possible. I think the biggest problem here is that AWS is very bad at building products. So they're great at building services and resources, but they are very bad at creating customer-facing products. We've seen that with Code Catalyst and all their tries to build something like that. So the usability of the code services is not what you are used to by GitLab, by GitHub, so having that developer life cycle in a console, like reviewing pull requests and merging stuff and seeing pipelines, that's way harder in AWS. And I think that's the reason with the code services.
Okay, where people can find you on the internet?
So, as I said, it's timos.de or on my socials at HoegerTN, so HOEGERTN, LinkedIn, Instagram, now TikTok, YouTube, whatever.
TikTok, you are dancing on TikTok.
No, I'm not dancing. I always thought about, TikTok is only about dancing, but now I'm having discussions about cloud sovereignty with 15K views.
Cool.
So obviously, TikTok also has a tech audience.
I didn't know that at all, really.
Me neither. But I started it, and now I have 15K views and discussions about the sovereign cloud.
Wow. Not bad. What's your handle on TikTok?
Also, HOEGERTN.
Okay, cool. So, thank you a lot, and see you next time.
Yeah, see ya. Bye-bye.